Welcome back to Cloud 42. I'm James. We are working on the Toolpost clamp for the Toolpost grinder. This is going to be a clamp to hold the Toolpost grinder to the AXA Toolpost on my lathe. Last time we cut the dovetails, so we have that done. The next thing we need to do is poke a hole lengthwise through this block for the spindle. That is an 1.5 inch diameter hole, and it's roughly centered in the block. Now, that is a lot of material to remove. And there are a variety of ways that we could approach that. We could bring back our old nemesis, the giant twist drill. If you've watched any of the previous videos, you probably already know that this drill is my nemesis. My lathe really isn't designed to push this size of a drill. It can be done if you step drill it up with a pilot, you go 1/4 inch, then 1/2 inch, then this, and then bore from there. You can do that, but I'd like to try something different. This is an annular cutter, sometimes referred to as a Rotabroach, sometimes referred to as a mag drill. And the difference between this and an ordinary drill is it only cuts around the periphery. The center is hollow. So what it does is it cuts down, cutting an annular groove, and then once it's penetrated through the work and you pull it out, there's a metal slug that comes out of it. So that metal slug is not converted into chips, and so you don't need nearly as much power to make a hole with this. Now, it's a little bit difficult to hold in a tool. It's got a 3/4 inch Weldon, double Weldon shank. So this is a 3/4 inch shank with 2 flats. And it's meant to be held in a mag drill. That's what these were originally for. Mag drill is a big magnetic-based drill that clamps down onto a piece of structural steel to punch a big hole through it. We don't have one of those. It really wouldn't be appropriate for this anyway. There's a variety of ways you could run this. We could do it with a 3/4 inch collet in the mill. It's a short grip, and there's enough material around the sides of this that you can get a good grip on it with the collet. Probably couldn't with an ER, but with an R8 you can. And you can run this in the mill, but my mill only has 2 gears, 2 actual mechanical reduction speeds. And the lowest gear has a top speed of 1200 RPM. Now what that means is if we're going to run this at its recommended 250 RPM or so for cutting through steel, we're going to have to use the speed controller to bring the speed way down from its maximum, like something like 1/5 of full speed. And what that means is that the motor is going to be pulling full torque at very low speed. So it's going to have maximum current flow through the DC motor and minimum movement of the fan, hence minimum movement of cooling air through the motor. And we don't really want to do that. It's very likely to bog down, overheat. I would much rather run this in the lathe. And the reason for that is my lathe uses a 2-stage belt reduction, so when we're running it slow, its slowest speed is 150 RPM, it will still be spinning the motor full speed. So the gear reduction or the speed reduction comes from a mechanical reduction which increases the torque and lets the motor run in its optimal range for cooling. Now, the question then is, how do I mount this in the lathe? I could try to do it in a drill chuck, but I don't have a 3/4 inch drill chuck. I could try to make some kind of an adapter for this, but by then you're sticking way out and got a lot of overhang. So I sketched up an arbor that goes in the MT3 Morse Taper 3 tailstock and has a socket 3/4 inch with 2 set screws for the Weldon flats. And this would work, but it's a lot of work. You've got to set up and cut a long taper, which is just about as long as the stroke on the compound of the lathe. Plus, this is really fiddly. The fit is fiddly. Turning some cylindrical outside with a cylindrical inside and keeping that concentric with a taper on the other end is tricky. There's a lot of steps to doing that in the lathe. And I was not looking forward to messing around with this. And then I realized something. The Toolpost set on my lathe came with this. And this is a boring bar holder for a 5/8 inch boring bar. But when I got to looking at it, I realized there's just a sleeve in here. You can push this out, And what's left is a 3/4 inch bore. And that 3/4 inch bore fits the annular cutter perfectly. So I was thinking I could drill a couple holes in here, put in bolts for the Weldon flats, and then I realized there's already a clamping screw in here, and that clamping screw is using kind of a little half moon cam, much like a spindle, like a Bridgeport spindle lock, and that will grip the side of this. So I can actually just put this in and clamp down on it with this screw. Is that 8mm? Nope. 5mm. What that is? Yep, 5mm. So I can clamp down on that, and that's now securely fastened in this boring bar holder, and I can put this in the cross slide of the lathe, get it centered up, and just punch this through the work, turning slowly in the chuck. Is this a really great idea? I think so, but there's only one way to find out. Let's go over to the lathe and give it a try. Okay, the first thing we need to do is we need to get the part set up in the lathe to run so that it's centered. And I want some copper soft jaws on these. I don't want to mark up the parts. This is just 25 thousandths copper cut and wrapped around the jaws. Okay. Now we're going to put it in something like that. Just kind of trying to eyeball it here. Get it close. Okay, the first thing I want to do is just check and just see how straight is it? Is it tilted one way or the other? There we go. Actually, that's not bad. So that's the high point, which means it needs to come this way just a touch. And that was way too much. Less than a thou. Now let's check and see how close we are to centered and make it centered. This is a rectangular piece, duh, so it's going to be a little tougher to do than something that's round. Try to center this up at the same height as the tool post. Okay. So that comes down to about 0. Let's see where we are on the other side. needs to come this way significantly. Let's see where that got us. So right about 58. So we need to move about 2 thousandths. Right about 4. Just over 5. Let me check this again because it keeps moving. Yep, still need to go. That's about 60. And we're half a thou. I'm good enough. I'm fine with that. And we're right about 5. And this way we're about half a thou less than that. Okay, that's good. Now let's check the face again. Make sure it's in there straight. Yeah, about a thou. That's good enough. Let's knock a hole in this thing. Now that should be my position. I've got a mark over here on the side showing me where the slide goes. I've got it on 0. Should be zeroed up. Get some oil handy. And let's start drilling. Now before we go very far, let's just look at that and see if that looks like it's in the center. That looks like it's in the center to me. Well, that seems to be working. Make sure we keep plenty of oil on it. Okay, this Sharpie mark I have on here is at 2 inches, and that's all the deeper this cutter will go. So we'll have to flip this around and cut from the other side. That's pretty nice. One annular groove. Yep, and we're almost 2 inches deep, which means we're most of the way through. Block's a little warm. I'm going to let it cool. I'm going to flip it around, grab it from the other side, dial it in again, and we'll punch it the rest of the way through. Okay, I've got it flipped around, indicated in. I got it within a half a thou, centered in both directions, and within a half a thou running out on the face here. So then we get back to my center mark here. I'm looking down here on the side. And as my mark lines up, bringing the cross slide dial to 0. So now the annular cutter should be right on center. Put that in the tool post. Start cutting. This should only have to go about 1 inch deep on this side. Now on the cutting pressure, I'm not really pushing it through. I'm just applying pressure and letting it cut. Should be getting close to breakthrough. And there it is. It's probably hot. Yes, it is hot. And now we have a hole. Oh boy, and they met up very, very close, right in the middle. I can feel the ledge between them, but they met. Okay, I am going to declare the annular cutter on the tool post a win, and we will see that technique again. Okay, let me get things cleaned up a little bit, and then we'll come back and run a boring bar through this and bore this to size. Okay, I got a boring bar in here. This is the largest one I have. It's about a 1/2 inch, 12 millimeter diameter boring bar with CCM TO602 insert for steel. Now, this the reason this looks like it's sticking out a long ways is because it's sticking out a long ways. This is about 3 inches. In fact, I've got it just over 3 inches so that it will just penetrate the back of this 3-inch part. Part's 3 inches. Bar sticking out just a fraction more than that, so that when the face of the tool comes up and makes contact, or almost makes contact, the bar will be through. So that's the plan. Now, as far as speed, this ideally would be running about 800 surface feet per minute in the bore, but I can't get to that with my lathe, because if I run it at 2400 RPM, which I really don't want to do with an unbalanced piece of steel in the spindle like this, in the chuck like this, you know, 2400 RPM is over 950 surface feet a minute. It's a little faster than I really want to go. Next speed down I have is 1200, and we're going to give that a try and just see what this looks like. It'll be a little slow for the carbide, so the surface finish will suffer slightly, but it won't matter because it's inside the bore and it's just a clamping surface. So let's see what we can do. Let me lower the speed here, or increase the speed. We're at 150 right now. Okay, let's see what 1200 RPM looks like. And that's more than I want to shake this thing. The part is centered, but the dovetail's cut. It might have been smarter to spin this. I wasn't planning on doing this in the lathe at the time, but it might have been better to do this first before we cut the dovetail, but I'm not going 1200 RPM. That's a pretty good jolt. Let's try 720. See what that's like. It's not great, but I can live with it. Let's take a cut here and just see what happens. And what are my feeds at? Okay, let's see what we got. Well, we got a cut. I think that's still too fast. I'm going to drop it again. That's better. Okay, let's see how much we can take here. Let's try 10,000. So I'm taking 5 thou per rev. Let's just see what this is like. Okay, that's fine. Let's take 20, see if it stops the singing. Oh. See what 30's like. This will be 10 until it catches up. Okay, that's a 30,000 step of cut, 5 thou per revolution. And the problem I'm having is the chips are coming around getting caught. So I'm going to rotate the bar slightly, change the angle at which it's presented, which unfortunately is going to mean I have to stick the bar out a little bit more to get my full 3 inches. It's going to be close. Let me stick it out just a little bit more. That bar sticking out so far. Let me try dropping the speed, see if we can find a recipe that works. Okay, let's try 20 thou depth of cut at this speed. Now this is 7 thou per revolution, 300 RPM. Okay, let's see how we're doing here. Make sure we're actually getting completely through the bore. Yep, it looks like we are. And the surface finish is horrifyingly bad, but there's not a lot we can really do about it if we have to run it this slow with carbide. Okay, see where we are. Now that we have a cut we can live with, we can start adjusting. One 429. Now you will forgive me if I use a calculator. That's 71 thousandths. Divide that by 2. That's 35 thousandths we got to take on the dial. And I'm going to take half of that at a time. And so we're going to take 18 to start with. And see where that leaves us. And we'll just use the rest of the recipe exactly the way it was. Okay. Okay, see where we are. One 461. So I want to hit 1,000th over because I'm about half a thou over on the spindle. So that means I need to take 20 thou from where we are right now. 10, 20 on the dial, and that should hit us exactly. This should be the last cut. Okay, let's see where we ended up. Looks like we're right at 1.5 and half a thou. Okay, looks like we're going to have to run a spring pass or something. Now let's actually back off and just take a little less than we had before because there's a lot of spring in this setup. See what this looks like. Boy, that's more than I want too. we go. Now in the end, this is going to be split 40 thousandths and with clamping screws to close it down. So the bore is slightly oversized. It's not going to kill anyone. Well, the surface finish is better. Let's see what the size is. Looks like we're about 2 thou over. Let's check the spindle. Okay, I can feel a little movement because we're about 2 thou oversized and the spindle's about 1/2 thou, so it's maybe 1.5 thou of movement. And that's just fine because we're going to have 40 thou of clamping range on this thing, so it'll be just fine. So the last thing I want to do is put a little chamfer, or at least break those edges. So I've got one edge here and I've got one edge on the back side. And I don't want to flip it around and true it up again, but there's a pretty good burr back there. So I think I'm going to use a threading bar, which I can use on the front, and then I can reach all the way through here and clean up that chamfer, clean up that edge on the back side. Okay, well, don't know if the chamfer's even, but it feels fine to me. Okay, I think, given that everything fits, that's the last thing we're gonna have to do in this setup. Let's pull it out and have a look. Well, that is the bore in the block complete. I'm very happy with how that turned out. We're about 1 thou oversized, but again, because that's going to clamp down on the spindle with a 40 thou split line, that's going to be totally sufficient. The surface finish isn't what I wanted, but I can certainly live with it. It is a lot lighter than it was. And of course, spindle fits through it, and that is starting to look a lot more like a tool post grinder. I'm curious, let's see how close we got to getting that hole directly in the center. Given how we set it up on the lathe and how we had it clamped at one end and sticking out, and we were just checking, to within 1/2 thou on the face to make sure it wasn't tipped. Let's see how well that actually worked. So we'll just measure the web thickness. This isn't, super precise. So the web thickness on this side looks like about 114. On this side, got to find the smallest point, 114.5. This over here, it's like about 113.5. And this looks like about 114. So that direction is, the alignment is fantastic. Let's try this one. Let's see here, 464.5. and 466. Now let's do those in the same order. Dovetail side first. .466. 466.5. 466.5. Yeah. So again, that is just fantastic. I'm not sure what was going on this side. I wonder if I got a bump or a hollow in the bore. Let's try that again. 465 and 464.5. So I must have had a bad measurement. Okay, so it went right through the center. Physics works, hooray. Okay, so what do we have to do to finish this? We need to punch some holes through and tap and countersink for the clamping bolts. We have to drill a hole and tap and put in the height adjuster, and then we have to take a slitting saw and slit it so that it can clamp down on the spindle. And then the tool post clamp will be done and we can put the grinder on the lathe. We'll work on that next time. Be sure to subscribe so you won't miss that video when it comes out. Thank you for watching.